On guys, in this video I'm going to solve some differential calculus problems. It's going to be very interesting. Let's begin. So the first question is asking, determine if the function one-to-one, even, or periodic. Also find the intervals of increase and decrease. So first they have given this function f(f) is equal to x square minus 4x plus 3. So first, in order to whether it is one-to-one, even, or periodic, we have to change this formula into this one. So you may ask how to change to this formula. Just what do you do? Just put the 4 here and subtract 1. So it will become x square minus 4x 4. We have to for these kind of questions, we have to bring this form into a plus b square. If you I am going to show you in the board. So if you see some kind of equations like this, we have to form an equation like one of this kind. It should be a plus b square format, or a minus b square. So if it's a plus b square, it's going to be a square plus 2ab minus a square plus 2ab minus b square, right? And if it's a minus b square, it's going to be a square minus 2ab plus b square. So in this case, it's similar to the second equation, a minus b square, but the only thing is to bring it to this form, I had to have a square right here. So that's why I said put the 4 and put minus 1. Therefore we can bring it to that formula, because x square minus 4 is 2ab, and 4 is 2 square. So that's why they have written a, like, let's say x square minus 4x plus 4 minus 1. So in this case I have this pattern right here. So it's gonna be like what, x minus 2 square. So if you expand this, you will get this answer, and 2 square minus 1. So this is the formula right here. So if you draw the parabola, like, it's going to be a parabola, because if you know x square, if positive x square is going to be what, opening up parabola, right? And minus 2, x minus 2 mean 2 units to the right, and 2 units to the right, and it's minus 1, therefore 1 unit down. So the graph is going to be like this. So from this one we have to check whether it is one-to-one. So one-to-one is, we have to draw a horizontal line right here for this graph. If the horizontal line meets two of the two lines of the graph, it means it's not a one-to-one function. Therefore from this graph we can say, if you draw a horizontal line, it will touch two lines. Therefore this is not a one-to-one function. And if it's even, to find whether it is even, we have to put f of minus x. So instead of x, if I put f of minus x, what is the answer I get? Like here's a thing. So if I put f of minus x, minus x square. So for this one, minus x square, and minus x, and the answer is going to be x square plus 4x plus 3. So this is giving different answer than f of x. Therefore, like, if it's a even function, f of minus x should be equal to f of x. Therefore this is not equal to f of x. Therefore this is not a even function. And to check whether it is an odd function, f of minus x should be minus f of equal to f of minus f of x. But if you like put the same thing for this equation and see, it's not equal. Therefore it's not an odd function. And also if you see, this graph is not about symmetric about y-axis. Therefore this is not an even function. Also graph is not symmetric about the origin. Therefore this is not an odd function too. And the third one is whether it is periodic or not. What is periodic means some pattern is repeating again and again and again. So for this kind of graph, the pattern is not repeating. Therefore this is not a periodic function. And they are asking, find the interval where it is increase and decrease. If you see this graph from negative infinity to 2, it's decreasing, right? That's why from negative infinity to 2 it's decreasing, and increasing from 2 to positive infinity. So 2 to positive infinity it is increasing. That is a increasing interval. And the second equation is f of x is equal to sine 2x, and they have given the interval minus 5 to 5. So if you see the sine x, at sine 0 degree the value is 0, and when sine is 90 degree the value is 1. But for this graph, this is sine 2x, it means it's this graph is vertically stretched by 2. Vertically stretched by 2 mean this is going to be like the value of sine x is going to be half of this one. Therefore so when if for example if the sine 5 by 2 is equal to 1, in this kind of cases what is going to happen? Sine 5 by 2 multiply by 1 over 2, so it's going to be what? Actually this is horizontally compressed. Horizontally compressed means you have to, like, if it's sine 2x, you have to multiply that one by 1 over 2. So therefore if it's sine 5 by 2, it's multiplied by 1 over 2. What is it? 5 over 4. So the value is going to be 1 at 5 over 4. So if you draw the graph for this, it's going to be like negative 5, it's going to be like this. Like if you went negative 5, it's going to be 0, and minus 3 by 5 by 4 is going to be 1, and 5 by 2 0, and minus 5 by 4 1, 0 0, and 5 by 4 it's going to be 1, and 5 by 2 it's going to be 0, and 3 by 4 it's going to be 1, and 5 it's going to be 0. So that's what the graph is going to be look like. And from this one, where the question is asking whether it's one to one. So if you want to know it's one to one, just draw a horizontal line. If it's touching two line, it's therefore if you draw this graph, it's touching already two line, right? Therefore it's not a one to one function. And to find the odd function, we have to put, like, to find even function, you have to put minus for f of minus x is equal to sine minus 2x. Therefore it's not equal to f of x. Therefore it's not a even function. But if you put f of minus x, it's sine minus 2x but equal to minus sine 2x. Therefore it's equal to minus f of x. So f of minus f of x is equal to minus f of x. Therefore this is an odd function. And the third one is whether it is periodic or not. If you see the question, they have given the limitation, like this graph is from negative 5 to 5. Therefore the limitation is there. So if there is no limitation, then it's periodic, because the pattern is repeating again and again. But they have given the limitation right here. Therefore it's not a periodic function. So by looking at the graph, they're asking what is increasing and decreasing. You see this graph, if any graph going from up to down to up, it's increasing. So from here, if you see negative 5 to 3 5 by 4, it's increasing. But we have to be careful. We shouldn't put the close bracket, like we shouldn't put the square bracket for this, because square bracket means that value should be exactly at this point. That value should be exactly that value, right? But in this case it's a curve right here. We don't know whether it's that point or it's increasing or it's, so that in that point we had to put the bracket that's not it's like curve bracket, right? So increasing is going to be minus 5 to negative 3 5 by 4, and here if you see this graph, minus 5 by 4 to 5 by 4 is increasing, and if you see here it's 3 5 by 4 to 5 is increasing. And if you want to see the decreasing, if you see this graph, it's negative 3 5 by 4 to negative 5 by 4 decreasing, and 5 by 4 to 3 5 by 4 it's decreasing. So those are the two intervals that are decreasing. And the next question is asking, given that f of x is equal to root of x plus 3 plus 1, and g of x is equal to 2 over x minus 1, and find the functions f plus g, f g, g of x, and f of g. And first question is f plus g, right? F plus g means simply we have to add it. We don't have to confuse with anything. Just simply add this x plus 3, root of x plus 3 plus 1, and add it with the 2 over x minus 1, right? Just add it. And the second question is f times g. Just multiply, We don't have to simplify or anything. Just multiply both two of them, like root of x plus 3 plus 1 multiplied by 2 over x minus 1. And the g of x is, when they are say g of f of x, what we have to do is we have to bring this f of x value and put it for the x value. Like for example, g of x is equal to 2 over x minus 1. Instead of this x, I'm going to plug the g of f of x value to the g of x. So g of x is equal to 2 over that x value is going to be replaced by x plus 3, root of x plus 3 plus 1. So 2 over root of x plus 3 plus 1 minus 1 is going to be the answer. So 1 minus 1 is going to be 0. So therefore the final is going to be 2 over root of x plus 3. And the last question is again, f of g is equal to what? So since we have done the similar question already, the f of g is going to be what? If instead of f of x for the x value, I'm going to plug the g of x value right here. So g of x's value is 2 over x minus 1. So I'm going to plug this value for this one. It's root of x plus 3 plus 1. Instead of this x, I'm going to plug this 2 over x minus 1 for that. So it's going to be 2 over x minus 1 plus 3 plus 1. So that is our final answer. And the next one is asking, find an explicit formula for the inverse of the function. Also find the domain and range for the f of f minus 1. So the question is asking f of x is equal to root of 9 minus 3x. So in this case, to find the inverse, instead of f of x, we have to write y, right? So y is equal to root 9 minus 3x. So to get rid of this root, I have to square it. So if I put square, it's going to be y square is equal to 9 minus 3x, right? So y square is going to be 9 minus 3x. So I have to find the x value to find the inverse. So x value is going to be, I can bring this 9 to the other side. It's going to be 9 minus y square over 3. So x is equal to 9 minus y square over 3. That's the f of inverse. F of inverse is going to be 9 minus x square over 3. So to find the domain and range, we have to know the graph. So in this case, if you don't know what the graph look like, I'm going to show you how to find the graph. Like this is a basic root of x graph. So I have a graphing calculator right here. So if I show that, it will be easier for you to understand. So 9 minus 3x, root of 9 minus 3x. So root of, where's the root? Root. Oh my god, where's the square root? Okay, square root is right here. Okay, square root, okay. 9 minus 3x. Okay, if you see this graph, okay, so if it's the root of x, this graph is going to be the opposite side, this side, right? And since it is minus, they turned into the other side. And if you take 3 common, negative 3 common, it's going to be x minus 3. That's why the value moved to the 3 units to the right side, right? So 3 units to the right side. And if from this you can find the domain. Domain is going to be what? X is starting from the 3 to the negative infinity. Like negative infinity to the 3, the domain is going to be. And the range, if you see, is stopping at 0. So the range is going to be negative infinity to, like in range is going to be positive. So it's going to be starting from 0 to positive infinity. So that's our range. That's our range, 0 to positive infinity, and the domain is going to be negative infinity to 3. So this is like for in this case, the domain of f of f is going to be range of f inverse, and range of f is going to be domain of f inverse. So if you find the domain for the f and range for the f, you are good to go with the range and domain of the f inverse. And the next question is asking f of x is equal to e to the power of 5x minus 10. Then in this case, to make this, to find the f inverse, I have to change this y is equal to my 5 by e to the power of 5x minus 10 into basic forms, right? So I'm going to put the ln y. So if I put the ln y, if I, instead of y, I put the ln y, right? So if I put the ln y here, I have to put the ln y opposite side too. So if I put ln y opposite side, ln y to the power of e to the power of 5x minus 10, e to the power and ln cancels. So when both of them are cancels, ln y is going to be 5x minus 10 equal to 5x minus 10, so I have to find the x value to find the inverse. So 5x is going to be ln y plus 10, and x is going to be ln y plus 10 over 5, right? So that's going to be our f inverse. So f inverse is going to be equal to ln x plus 10 over 5, and to the basic e of x graph. So I'm going to Google an E of x graph. Okay, this is our E of x graph. If you see this value, like this is going to be same every time. So in this case, if you want to see the domain is going to be what? It's going to be coming. Coming from the negative infinity to positive infinity. That's our domain, and the range is going to be what? Starting from the 0 to positive infinity. So that's our range. Positive infinity. And the next question is asking f of x is equal to 9x minus 1 x plus 3 over x plus 3. What is the f inverse, right? So to find the f inverse, as you know, we switch the x value and find the x value, right? So y is equal to 9x minus 1 over x plus 3. So I switched it into x plus 3, bring it to the other side. It's going to be y is multiplied by x plus 3 equal to 9x minus 1. And if I multiply the bracket to the other outside, it's going to be xy plus 3y equal to 9x minus 1, and xy minus 9x is going to be minus 1 minus 3y. And if I take the x common, it's going to be x to the bracket y minus 9 is going to be equal to minus 1 minus 3y, and x is equal to minus 1 minus 3y over y minus 9. So this is going to be our f inverse. So whatever the value be x value, it's going to be f inverse, and it's going to be equal to minus 1 or minus 3x over x minus 9. And f inverse we can, since this one is minus 1 minus 3x over x minus 9, so since this is minus, I'm just going to multiply this one by negative 1. So to make it positive, it's going to be 1 plus 3x over 9 minus x. So to find the domain for this case, so domain is going to be what? So if you look at the equation, the x plus 3. So the problem with this question is the x shouldn't be negative 3, because if it's negative 3, the bottom will be 0. So the function does not exist. So in this case, I have to avoid the 3. So if I avoid the 3, so in this case, domain is going to be whatever the value except the minus 3. So if you imagine, let's find the graph for this one. So okay, I'm going to draw the graph for this one. Okay. So y is equal y is equal y is equal 9x minus 1, 9x minus 1, 9x minus 1. Let's put the bracket here, so it will make it clear that it's common for everything. And 9x minus 1 over what? 9x minus over, our question is 9x minus 1 over x plus 3. 9x minus 1 over x plus 3. So if you see the graph, that's the graph is starting from the negative 3, right? So if you see the domain is going to be whatever the value, it's going to be like this. So you will get an vertical asymptote and a horizontal asymptote, and domain is going to be starting from negative infinity to minus 3, and from then after the minus 3 to positive infinity. That's going to be our domain. And range is going to be what? Range is going to be, since this one is true right here, it's going to be if it's in negative 3, then negative 3 minus 18 minus 17. So range is going to be at it's not equal to 9. So range is going to be, y shouldn't be 9 at all, right? So because if you put 0 for this one, it's going to be 0 0, so minus 3. So according to this graph, y shouldn't be 9 at all. So the range is going to be y is not equal to 9, and whatever else the number is going to be it's going to take whatever the number. So it's going to be negative infinity to 9 and 9 into positive infinity, because simply you put the minus 3 value for this one and see. Let's see. So 9, so when y is equal to 9, x plus 3, so 9x into 9 is 27, 9 to 9 81 minus 9, so why shouldn't it take 9? Oh, because, okay, now I understand. So if you see the f of inverse, f of inverse our f of inverse is equal equation is minus 1 minus 3x. So in this case, if you put 9 for the x, which is y value in case, because we've switched the, if you remember, we switched the y value for the x value. So if I put the 9 for the x value in this case, it's going to be 0. So we shouldn't achieve 0 at all. Therefore, that's why it's 9. That's why it's 9, and it shouldn't be equal to 9 at all. Then the final question is solve each equation so inequality for x. So the first question is asking log 3x plus log 3 2x minus 1 is equal to 1. So note the domain is greater than x, right? Domain should be greater than 0, because if you like, let's see a logarithm graph right here. So log is never be below 0, like the domain. If you see the domain, it's x is never below than 0. So that's why it should be never below 0. So first let's solve it as an equation. Let's treat this one as an equation. So x minus 1 is equal to so 2x minus 1 should be greater than 0. That's true. And if you take x is greater than half, right? X should be greater than half. That's what we have to find out first, because after we solve the problem, if you get any answer that's below half, we know that's not true, right? And log 3x plus log 3 2x minus 1 equal to 1 according to this equation. And log 3, if I take the log 3 common, it's going to be 2x multiply this x, 2x square minus x equal to 1. Then I take the logarithm to the other side, and because if I bring this logarithm to the other side, it's going to be what, 3. So 3 to whatever, okay, 2x minus x is going to be 3 to the power 1. So if I bring this 3 to this side, it's going to be 2x squared minus x minus 3 is going to be 0. So if I factor it, it's going to be 2x minus 3 plus multiplied by x plus 1 equal to 0. So if you see, x have two different values right here. X is equal to 3 over 2 and x is equal to negative 1. As we discussed before, x is negative is not in the domain, because as we mentioned before, x shouldn't be never be below the half, because if it's below the half, it reaches 0. So it shouldn't be below. So we have the x 3 over 2. That's the answer. And the final question is asking e to the power of 3 minus x is equal to greater than ln 5. So we have to solve this. E to the power of 3 minus 4x is greater than 5. So if I multiply if I put the ln by both sides, if I multiply both sides by ln, e and ln going to cancel, and 3 minus 4 over 6 is only ln into ln 5. So 3 minus ln into ln 5, if I bring the 4x to the other side, it's going to be equal to 4x. So x is equal to, if you solve, x is equal to x is going to be lesser than 3 minus ln into ln 5 over 4. That's our final answer. I hope you guys enjoy this video. See you next time.